And we have to see if it builds up and how it goes, because we have taken him from the 2 milli to 25 Tesla since 7 o'clock in 3 hours.
Mr. Kesh, I didn't have the sound on until that last sentence there, so people don't really know what's going on at this point. Maybe you could just quickly review what we're seeing in front of us here and what the breakthrough is that you are understanding.
In the background, we're talking to you from Kesh Foundation Center, and what we have achieved is that, as you know, the new reactors, the 4 small reactors you see in the background, have been, don't touch, it's taken, Arman. There's no problem, just, okay. It's taken us since 7 o'clock tonight to start this series of tests. It's the first time we have managed to bring the reactors together in a full formation. These are very tiny reactors. We have mounted, if you can see in the background, if you can show it, Arman, we have mounted the heavy field detector, literally looking into a space. This space is not a space where the reactors are operating. This is more or less the focal point of the pyramid. So the detector is looking into an empty space and measuring a balanced magnetic field between 4 reactors loaded with GaNs. It's the first time GaNs material ever been tested this way. And the magnetic field created between the 4 reactors, which are about 2 centimeters in diameter, and they have about, what, 20–30%, if that, of GaNs, and the rest water. And the speed of rotation, we have decided to be at about 2,000 RPM. The total voltage and amperage of the system, if you can have a look, if you can see them, is about 1 core, because of the polling on it, is less than or around about 4 watts. The others are about 2.8 watts, and one is less than 2 watts. So very, very little energy is used to create such a pulses of magnetic field. Initially on Saturday, we saw the first increase, but Arman and I, we were watching it and something happened and it disappeared. We left it. We managed to reach a number we've never seen before. And this afternoon, we started from 7 o'clock. And this is literally looking at every single pulse which is made in the core, in the space between the reactors. So we have achieved the space, literally plasmatic magnetic field of 25 Tesla. That is literally looking into the abyss and looking at what the field can be reached. We do not expect a flight tonight, but as we have achieved 25 Tesla in a pulse reaction and the other dimensions are increasing, we might not see any changes or very slight changes overnight, but it is historical in a way to achieve such a thing, because in early 2000, the Dutch organization managed to achieve 16 Tesla with a famous levitating frog. We have already passed that at 25 pulse, and we are heading into one of at the moment, we are somewhere past the field strength of 1 gigahertz, which is used for a spectrometer. If we reach 35 or 40, we achieve the strongest continuous magnetic field produced by non-superconductive resistive magnets. So what the reason we put this on is that we stop overnight and you people in Canada can follow it, or people around the world. As I said, we do not expect, unless something happens strange, any, what do you call it, a spectacular condition, but everything is possible because the fields are building up and we know overnight things happens quite rapidly here. If we can turn this, which on the top reads for about 11 millitesla, at this kind of strength is over the strength of a typical magnetic special refrigerator magnet. So this, to understand, you're looking into a space. We are not looking into a material. So even at 11.58, we have passed producing a solid magnet condition for a refrigerator, about 25 Tesla pulse. We have passed levitation point of live being, and we have turned the system on and off as a highest peak read maximum, and it builds up to building up back up to the same and building up again. So this is a continuous process. If we can look at the graphs, maybe you can see the graph condition. If it is clear, yeah, it is. You see the peaks coming in. These are the peaks which are built. You can see the peaks. These are huge peaks, around 25 Tesla, coming out of the reactor. The blue line is now you see a collective. The blue line is the magnetic gravitational field coming out of the reactor, and is getting repeated more and more. It's so high, which diminishes the vertical and horizontal field strength. So the peaks are building up in the Z direction. What you see as a peak is the fields which flowing out of the reactor towards the. You see another peak. These peaks are building up.
These peaks, when we look at that yellow line at the bottom, that means these peaks are well above the magnitudes of that yellow line at the bottom, or that white line.
Yes, the yellow line at the bottom is 0. Now you see a combination of X, Y, and Z.
Yeah.
And when you see the peaks, it's so high than the X and Y that it becomes total line, yeah. And you see it again, it's becoming repetitive. So we are at the moment at, if you look numerically, we are still at 25,000 millitesla or 25 Tesla. Is not a one-off. Is repeating itself, as we can see on the graph. And it
so the yellow lines are base? Are those yellow lines a base?
The yellow line is the base, yeah.
Environment.
Yes. Yes, because we have measured the environment, but when we get the peaks are so high. From there it is. These are the fields which are coming out of the 3 reactors together in the space. We are looking, all these measurements are looking into literally abyss. I mean, it's nothing there. We are looking into a shaft which is connecting to the, what do you call it, the master core on the top, and the 3 cores are sitting at the bottom. I think we can take the camera to have a quick. If you can take it, yeah, you take it close so that it can be seen. Yeah, why not? We're going live. We invited people to the house. Let them see what furniture we have. No, you don't. Just let me take this off. And then you can go. Yeah, okay. We go with the laptop. Yeah, we go there. If you go with that, it's okay. You hold the camera because you got to see what you're showing you to the. It's opening. Okay, well, we go. You got to realize we were not planning for such a thing. And as we said, when we have a breakthrough news, we show. This shows a huge plasma production in peaks on regular basis. And as the reactor builds up, Arman, you got to see what you're showing. Okay? Give me this out so I'm not in your way. Yep. Okay. Yes. See, you got to show. Go back if you can to the back to show the detector where it is. The detector is looking into, go closer to the back side where you can see it. The detector is looking into the center of the space. If you can.
I can go from there.
Go from the other side, no problem. Can we go forward? This is a pure plasma. You see the black, Arman, you can show the black detector. You got to go up. No, go up, yeah. This is the detector. Don't move too fast. You see the black detector in the middle? You can show it with your finger that they can see what they're looking for. That's there. And it's looking into space. It's not looking at any reactor. So this is what we think is the highest maximum peak point of the pyramid, where we should see the interaction of magnetic gravitational field of the 4 reactors in conjunction with the Earth to take place to create the first lift. This is in so many ways thanks to Arman and the time he spent to building such a beautiful system. You see the 4 reactors. The top reactor is here. I tried to show you that. That's the top reactor. And then we have the 3/4 base reactors. I'm producing 25 Tesla in the middle of the air with reactors rotating with less than maybe less than 1 or 2 grams of GaNs. Yeah, no more. So it has shown that GaNs is a, what do you call it, dynamic plasma. And there is no winding, there is no energy supply to any of the cores. It's just rotating higher speed plasmas, which is centrifuged or in a way brought to a center point. Tomorrow, if we don't achieve what we are looking for now, is we managed to break through. It's just building up to bring the peaks into a straight line. We have 2 choices. We're going to explore the increase in the speed, or by end of the week, changes in the GaNs material, or even mixing the GaNs materials. But on the other hand, tomorrow, our plan is to do what we call remote control, with Armand being in the teaching room some 100 meters away, and with his thoughts, because he's built the reactors are connected to him, that he can decide the speed of the motion or increase of the fields of the reactors. So what we do, we're going to go back on the base foot, and we're going to leave you as we break up for, it's about 8, 9 o'clock here for the day. If you want to stay live on the live stream, or we can close down and come back to you tomorrow, whichever you decide.
Mr. Kesh, is it possible that you can broadcast your camera live to live stream?
Yes, of course. That's why we came on.
Right, but we're on Skype, so can we?
I thought you already went on the live stream.
Yeah, no.
Uh-huh. Do you want to do it? Do you know how to do it? You have to tell Marco
We can try, huh?
what to do, and then we don't mind. Huh? We are disconnected from the camera for a few seconds till we reorganize ourselves. If you teach us and you want to go, and somebody can keep an eye on the whole situation overnight, then it'll be good for, what do you call it? For the, yeah, it's looking here. Look. What? Yeah, but it says nothing might happen, but something interesting might happen. But in a way, it was important to record such achievements because those who are in plasma technology and in nuclear technology will understand the significance of this video in so many ways. From plasma technology is very much as good as landing on the moon, if people understand this what do you call it, this principle. If you ask what do you call it, the guys who understand the game to watch the live stream and be able to see the numbers and how it changes, this is significant. It's absolutely important what has been achieved for the, what do you call it, for such a small systems. So if you want, whatever you want to organize with, you brought this down, no? Does it come down, or is it the one which has all the datas on it? No? This is what we brought down to write. It's okay. Leave it there.
Yeah, we'll work with the guys there, Marco, and get that
Can you
set up
see
for
the
live.
figures? The important thing is somebody can see the figures on the dial. That's our biggest problem. Can you? Yeah, but you have to have a view of the background machine, because if anything happens, we want you to see that we recorded.
Oh,
Because
yeah.
we're going to...
Over just a little bit more.
No,
The other way.
No. That way, go that way, that way, that way. That way.
Other way.
This way? Me?
You had it. You had it good. Yeah. You back up a little bit. The other way. Other way.
Back up. But you can't see the system in the background.
No, go left. Go left.
Go left.
Go left. Go left. Keep going. Keep going. Keep going. No, it's not there yet.
But we
Keep
don't
going.
see the... Wait, let's just do something else. Just wait. Now
Okay.
come this way. Because we want you to see the reactors and the systems.
Right.
So if it's here.
Oh, the good numbers. Oh, just about had it.
Let us do a little bit of adjusting.
Oh,
No, it's okay.
that's
Can
great.
you see it now?
Yeah, I can see the number. There's a little bit of reflection on it, but if you can,
Go up a bit.
yeah.
Yeah. Okay,
25,
you see the weight.
84. Yeah, I can read
Yeah,
them all.
you see the weight of the system is 11 kilo, 860 gram. That's the top number. The B is in millitesla, which is 11, but that goes average of the peak, and then you have the peak at 25,274 in a Z, which looks at the field coming up out of the pyramid in a way. If it goes minus any of the figures, which means the reactor is pulling in the fields. But because the sign is plus, it means the fields are going to the direction of the sensor, which means, what do you call it?
Do they see inverted picture?
Do you see? No, they see the full picture because they
Yeah,
can
but
read the numbers.
Yeah.
We see it inverted.
Why we see inverted?
Do you see a full or do you see inverted?
That's good.
It's
They
only
see-
inverted for you. It's only inverted for you.
It's inverted for us. Okay, now let's.
That's what they
Why?
see.
Yeah,
That's what they see.
But why we see that?
That 25,000 is not very clear. It's projecting.
From that.
Yeah. So you see how to do it. Do you see it better? No, you can't.
No,
Because
no.
then you can't see the reaction. Actually, it's good in the dark because if it flies, you will see it. Yeah, when it lights up, you see it. We call it the light, what do you call it?
It's possible from this angle,
Yeah, but we have to see that. That's part of our problem. This is
Can
what
you
we
move the
really
camera
do.
back?
Just, we're
Can you
gonna
move the
do
cam-
something. Because you can see the reactor.
Yeah.
Is it better?
I can still read the numbers. They're a little bit blurry, but I can read them clear.
Uh,
Well, that's better. That's even better right there.
That's better. So you can see the reactor, you can see the numbers, and we don't know if anything is going to happen because that's us looking at the reverse. But what do you call it? Nothing might happen, but if it happens, it's alive. You can see exactly what the story is. It's okay. Very nice. I think if you go through the scientific book, you'll find out this is a breakthrough in so many ways.
Yeah.
If we can achieve further, but you will see, and we go to sleep. Yeah, but being able to produce is a good camera. No, I don't think we see lift, but in being able to what do you call it, to achieve 25 Tesla in fresh air is a huge achievement.
Now, Mr. Kesh, are those numbers locked right now, or do they change periodically?
They
What's the-
changed. That's why we put it about an hour ago, or about 3 hours ago. It was 2 milli Tesla, 3 milli Tesla, and then we were happy with 8 and 9, and we thought it's good. And then it went up when it went to 19,839, and then it jumped to 25,274, and total reaches. Pardon? The top one, is the what do you call it? Supposed to be the average life, yeah. The next one, 7.2, is the x-axis. This is the field surrounding the system, the star formation on the x-axis. Second reading, which you see at 11,287, is the vertical, what is coming to the detector. And the bottom one, 25,000, is what field is coming out of the, what do you call it, the star formation to the detector. When it's positive, it's what's coming to the detector. When it's negative, when it's going away from the detector. And when you achieve the, what do you call it? Can I have that list, please? When you achieve the position of the lift, the field goes to around 100 plus. And this will create a huge gradient flow between the X and Y and Z. And then you should start getting what we call as a magnetic airflow or magnetic cycle. And then it starts feeding on itself, and then it shields up, and it becomes one cell. And that's the time when you see the, what you call the bright light as a sphere. So you should be able to see a horizontal flat plate light to start with, and this flat plate light builds up to a sphere in a very rapid way. And this is, I think it will not be achievable because I know there are some things need to be changed, but as we said, we do it at the time as it goes. But don't forget, there are no magnets used here. There are no, what do you call it, radioactive material used here. There is no motors which their magnetic field can interfere with the center column. All the motors are sitting below level, so everything is above the three platform plates. And on the other hand, the whole structure weighs less than 12 kilograms, which lift for this should be quite feasible in a very rapid way. But if you look, I don't know if you can see it, we're getting reverse Z direction flow, which means here, if you can see this peak, I don't know if you see it, as long as you have that reverse flow, it means the system is absorbing fields from the environment. Most probably X is in the same position. When if you are monitoring and you see a continuous black upwards, it means then we are heading for a full lift. We had this on Saturday, but somehow we lost it. I guessed that was because the detector was sitting outside the system. This morning we actually mounted the detector on the whole set, which means it stays as part of the field. So we have achieved something very interesting, and if somebody wants to keep an eye on it, Marco will go on a live stream and we stay online. Can you do that, Marco?
Yeah, we should try that.
We should try. I'll give the headphone to Marco for you to set it up that if you want to carry on, you can go on with it. Rick, did you get my email? I sent an email to you and Vince.
Yeah, we got it.
You got it. You know where we stand, yeah? Okay. We got to talk. We got to talk about it. Okay, no problem. Okay, bye from